All right, everybody, welcome back. Today we are going to be talking about the x-intercept of a graph. So yesterday we talked about the y, today we're going to talk about the x. Our objective is that we can locate and find the x-intercepts if we are given a graph and the equation of a quadratic. So remember, a quadratic function is any function that takes this form. Ax squared plus bx plus c is equal to 0. Anytime you get something that looks like this over here, this is going to be a quadratic function. And anytime we're dealing with a quadratic function, it's always going to look like a parabola. Now, the x-intercept, right? Yesterday we were talking about the y-intercept. Today we talk about the x-intercept. So this is where our graph crosses the x-axis. So looking at our graph, right, this is our x-axis right here. This is our x-axis right here. And this is our x-axis right here. Now, it looks like not in every graph can we see them all. Because in this one, we can't see where our graph crosses it. So if our graph doesn't cross it, we're just going to say, let's say no solution. Or not shown. I'd take either one. I think actually I'm going to go with not shown because I think that's what I use in Schoology for your answers. Not shown or no solution. It could be either one. Now, here's another one. As you notice, we actually crossed this line 2 different times. Once here and once here. So we're going to get 2 different x-intercepts. The first one, we're going to have -2, comma 0, right? So for this first point, this point would be -2, comma 0. And for the second point, this one goes through the point 0, 0, so we can just write 0, 0 over here. Now, one thing that's going to be unique is whenever you guys are writing these down today, this and this will always be 0 for us, which makes our life kind of a little bit easier as we start to think about them. And that's true because these are x-intercepts. Now, here's another one. This one looks like we're going to have 2 different points. So maybe I'm going to set up my parentheses right away. And just like we said a minute ago, the second part's always 0 in these. So for the first part, well, there's -6. And for the second one, here's -2. And just like that, we got our x-intercepts. Not so bad, right? So let's do a few more of these. So coming on over, I'm going to highlight my x-axes right now, just so that I can easily see what we're talking about. Once you got all those highlighted, then we just need to look. Looks like this one crosses it twice, so we're going to set up our ordered pairs. Remember, 0 always goes in the second slot. Since this one's -3, we'll put -3 right there. Since this one's -1, you put -1 right there. That's it. That easy, that doable. Here's your next one. Now, this one's unique. And the reason it's unique is because this one kind of crosses in the middle, and I can't see where this one crosses. So if that's the case, we just got to kind of take our best guess. So it looks like this one is going to cross at, remember 0 is the second number, looks like a -4.5, because that would be in the middle there. And then since we can't see the other one, we don't even need to write it. So that's it. Look at this one. Does it cross? No. So we're going to say not shown. Here's your next one. This one looks like we can see it cross twice. Once here, once here. So we're going to list out our points. Remember, 0 goes in that second slot. This is a +1 for this one, and this is a +5. Not bad. Here's another one. Looks like we can see it cross twice. Once here, once here. So we need 2 ordered pairs then. 0 always goes in that second slot. So looking at the first one, this is where 3 would be, and this is where 5 would be. So 3 and 5 go into those first slots, and you're done. Nice job. Here's another one. Looks like we're crossing twice. So again, grab your parentheses. 0 always goes in the second slot. Looks like the first one is -5. Looks like the second one is -1. Here's another graph. Well, looks like we didn't cross it. If we don't cross it, we say not shown. Last but not least, here it is. Coming over here, looks like we get 2 x-intercepts. So we need 2 sets of parentheses, and we need 2 zeros in the second slot. Looks like our first answer here is -6. Looks like our second one is -2. And you're done. So it's relatively easy to identify those x-intercepts if you have a nice graph. Not always going to get a nice graph, but we did today. But here's the question. How do you find it, right? The same question we asked yesterday. How do we find, I think I should have had x-intercept here, if you can't find it on the graph? Because that's going to happen sometimes. So if we can't find the x-intercept on the graph, then we got to get a little bit more creative. Now, on this one, we can see that our x-intercepts are 3 and 5 here. So 3, 0, and 5, 0. We can see those already. Now, this is the graph of that. So we need to find a way to get from this to this without one of these. Okay, so let's talk about how we do that. Whenever this happens, if you want to solve this, first thing you want to do is you want to factor this. So you want to come over here and do the x. Remember, you put a 1 here. 1 times 15 gives us 15. We're going to get a -8 on the bottom. And then we're going to have 1x over and 1x over. Now, we're looking for two numbers right now that are going to multiply to give us a positive 15, that are going to add to give us a -8. This is where we've been for a while. We keep going back to this idea. So, two numbers that multiply to give us 15, that add to give us a -8 would be maybe a -5 and a -3. Yeah, I think that works. Add this, that works out, that works out. So my final answer here is going to be, looks like 1x minus 5. And on the other side, I'm going to get 1x minus 3. Now, looking at these for a second, we're going to use our zero product property. So we're going to say x minus 5 equals 0, and x minus 3 equals 0. And if we solve this to get x alone, we add 5 on both of these, we get x equals 5, which, hey, look, that matches up with this one. And on the other one, if we add 3 and add 3, we get x equals 3, which matches up with this one. So the way that we get from this to these without using a graph is by factoring. So that's what we're going to practice right now. So here's another graph. They want us, it says y-intercept again, I must have made a mistake making these, find the x-intercepts if we are given these equations. Here's how we're going to do it. We're going to factor. So come on over. 1 times 3 gives us a 3 up top. -4 goes on the bottom. This will be 1x and 1x. We're looking for two numbers that multiply to give us 3, that add to give us a -4. And of course, that will be, I think, a 3 and a 1, but I think they both need to be negative. So -3 and -1 would work there, and -3 plus -1 would work there. So my factor will be x minus 3. That came from this side. And my other one will be x minus 1. Great. Now, at this point, remember, what did we do last time? We took this first term, x minus 3, and said equals 0. And then we took the other term, x minus 1, and said equals 0. Now we just want to solve. So come on over. We're going to add 3 to both sides. So that's one of my answers. Add 1 to both sides. That's my other answer. Now remember, when I write x-intercepts, I always write them as points. So we're going to make my 2 points. And 0 always goes in the second slot here. So we're going to have a 0 there and a 0 there. So I'm going to put 3 up in this first slot. And I'm going to put 1 in the second slot. And these, ladies and gentlemen, are my x-intercepts. Now we had to do a little bit of work to get them. It's not quite as easy as looking at the graph. But this will work every time. Let's do another one here. So coming on over, we're going to start by factoring. So 1 here. 1 times -20, that's -20 going up top. On the bottom, this is a -1. So we're looking for two numbers that multiply to give us a -20, that add to give us a -1. I think 4 and 5 are my two that are going to make this work. So how about a -5 and a +4? I think we got it. Works for the top, works for the bottom. Nice job. So now that means our factors are going to be x minus 5. That came from here. And x plus 4. That comes from over there. So just like we did before, we're going to take these and set them equal to 0. So x minus 5 equals 0. That was this one. Now this one. X plus 4 equals 0. Let's solve. Add 5. Add 5. X equals 5. Minus 4. Minus 4. X equals -4. You're almost there, guys. Remember, we write these as points. So 0, comma, Block almost made a big mistake. Let's have my parentheses. Remember, 0 always goes in the second slot when we're dealing with the x-intercept. So I'm going to put a 5 here and a -4 there, and those are my answers. Great job. Let's do one more of those together. We'll save the last 3 for just extra practice if you want it. So here we go. If we need to find the x-intercepts and we don't have a graph, we factor. So 1 times 35, that's 35. Positive 12 goes on the bottom. Okay. 1x here, 1x here. Two numbers that multiply to give us 35, that add to give us 12. How about 7 and 5? I think they're both positive too. So our factored form would be x plus 7. That came from here. And x plus 5. That comes from over there. Now we're going to use that thing called the zero product property. We're going to say this equals 0. And we're going to say this equals 0. To wrap this up, let's get x alone. So we're going to minus 7, x equals -7. On the other side, subtract 5, x equals -5, just like that. So, last part. Grab your parentheses, put your commas in, put your zeros in that second slot. Take your first answer here, slide it in there, -7. Take your second answer here, slide it in there, -5. Those are your two x-intercepts for the problem. Thank you guys for watching the full video. If you have any questions, please just make sure you're reaching out and asking. Remember, I'm always here to help. Thanks for watching. Have a great day.